All right, in this video we are going to go over how to do the most complex stoichiometry problem you'll have in this unit, which is a mass-to-mass problem. In other words, you'll have a problem where you are given grams or mass of one substance and you're asked to convert that to the mass of your unknown substance. Okay, so here's an example of a problem that you might be given that is mass to mass. And what you want to do when you get your problem is you want to make sure you read it carefully and be able to identify the given, so the substance that you're starting with, as well as what quantity of it you're starting with, and identify your unknown. So what substance are you trying to find a quantity of, and what quantity are you trying to find? So in this video I have my unknown in red and my given in blue. So the question reads, how many grams of iron 3 chloride are produced when 15.5 grams of iron react with excess chlorine? Okay, so this is definitely a mass-to-mass problem, right? Because we're starting with a mass of iron. This is our given, 15.5 grams of iron, and we're converting to a mass of iron 3 chloride, so mass to mass. The first thing you need for any stoichiometry problem is a balanced equation. So our balanced equation for this reaction is as follows. Okay, for every 2 moles of iron that react with 3 moles of chlorine, we can produce 2 moles of iron 3 chloride. Okay, and we're going to use this balanced equation to convert between iron and iron 3 chloride. So let me just go ahead and rewrite what we're given. So our given is 15.5 grams. Okay. Our unknown is grams of iron 3 chloride. So this is what we're trying to find out. Okay. So after we have our balanced equation, our next step is going to be just to rewrite our given, right? So I've rewritten our given up here, 15.5 grams of iron. And then we want to convert that to moles so that we can use the mole ratio from the balanced equation. So to go from mass to moles, we simply divide by the molar mass. So 15.85 grams of iron, that's the molar mass. So the first step in these mass-to-mass problems is to divide by the molar mass of your given. Okay? Once you divide by the molar mass of your given, then you'll see that you are left with moles of your given. Okay? And after we do that, once we have moles of our given, we can then convert it to moles of our unknown by multiplying by the mole ratio from the balanced equation. So multiplying by the mole ratio, excuse my handwriting. So the mole ratio in this problem of iron, so we want iron on the bottom, right, because we want our given on the bottom. And in front of iron, we have a coefficient of 2, so that's where this is coming from. So for every 2 moles of iron, we produce 2 moles of iron 3 chloride, right? We want our moles of our unknown, which is iron 3 chloride in this case, to go on the top, and the 2 comes from the balanced equation. So if we stopped there, we would have moles of iron 3 chloride, but that's not what we're looking for. We're looking for grams. So in our last step, we are going to multiply by the molar mass of our unknown. Okay, we're going to multiply by the molar mass of our unknown to determine the grams that we have of that substance. So the molar mass of iron 3 chloride is 162.35. Okay, and we got that by taking the sum of the molar mass of iron and 3 chlorines. Okay, and those all added up to 162.35. So then we're going to go ahead and do the math here, right? So we do the math, we're going to multiply by whatever's on the top, divide by what's on the bottom. So in your calculator, if you've got that out, please go ahead and type in 15.5 divided by 55.85 times 1, right? 2 over 2 is 1, times 162.35. So go ahead and pause and do that math. And you should end up with a mass of 45.1. Got 3 sig figs there, 45.1 grams of iron 3 chloride. So let's go ahead and summarize what we did in that mass-to-mass problem. So here are kind of the steps to figure out a mass-to-mass problem. The first thing, you want to make sure you've got a balanced equation. Whether or not I give that to you or you've got to write it, make sure you have a balanced equation. Okay, in mass-to-mass problems, you'll be given the mass of substance A. So the first thing you want to do is convert that to moles. How do you convert the mass of your given substance to moles? Divide by the molar mass, okay? After you've divided by the molar mass, then you would have moles of A. So now you're ready to figure out moles of your unknown, moles of B, and you can do that by multiplying by the molar ratio from the balanced equation. So after you multiply by the mole ratio, to convert to mass of your unknown substance, you're going to convert to grams by multiplying by the molar mass, okay? Essentially, your work, if you did it all in one full swoop, would look like this. So you've got mass of your given, that's A, divided by its molar mass, okay? Then you're going to multiply by the mole ratio. Okay, that's what this conversion factor is. You get the N, the values from the balanced equation, and then you multiply by the molar mass of your unknown. Okay, and that should give you the mass of your unknown, which is B. If you are using your foldable that we did yesterday, this is just another way to show you those steps. So if you're doing mass to mass, start by just rewriting the mass of your given from the problem. Multiply that, so let's go ahead and make this a multiplication problem. Multiply that by the conversion factor that has molar mass on the bottom. You get that from the periodic table, 1 mole on the top, right? So just take mass of your given divided by the molar mass. And then we're going to multiply that by the molar ratio from the balanced equation. Again, you want to make sure that you're putting the coefficient of your given, so that substance that you start with, on the bottom of the conversion factor, and then the moles of your unknown, the substance you're converting to, on the top. And these numbers just come from the balanced equation. And then finally, the last step will be to convert moles of your unknown to mass, and you can do that by multiplying by the molar mass. Okay? So 3 steps. Okay? First, take your mass of your given, divide by the molar mass, then multiply by the mole ratio, moles of given on the bottom, moles of unknown on the top, then multiply by the molar mass. So let's go ahead and have you try one. I want you to make sure that you're putting these examples in your ISN, page 25. So here's the example that I'd like you to try on your own. I'd like you to calculate the mass of oxygen produced when 10 grams of hydrogen peroxide decompose. Okay, here's your balanced equation. Go ahead and pause the video and try to work through this. And when you're ready to check your work and check your answers, press play. Compare your work to mine and let me know how you did. All right, so hopefully you've done your work. Here is what it should look like. And here's the answer. So 10.0 grams of hydrogen peroxide would decompose into 4.7 grams of oxygen. So we had our given divided by the molar mass of hydrogen peroxide, which is 34.0, multiplied by the mole ratio. So our mole ratio, we have 2 in the bottom, okay, 1 on the top, because hydrogen peroxide to oxygen are in a 2-to-1 ratio. And then we multiplied by the molar mass of oxygen. Don't forget, oxygen is O2, it's diatomic, so you have to take the molar mass of oxygen times 2, so 16 times 2, which is 32. So if you've got it set up correctly, then make sure that you're doing the math correctly. Multiply by whatever's on the top, divide by whatever on the bottom. You should end up with 4.7 grams. And you are good to work on the problems in Station 3 of your limiting reactant activity. Please let me know if you have any questions.